Hi folks, it's been a while since we did another problem on Leetcode. So let's try to do today Leetcode 138, which is a very interesting problem by the way. It has been characterized as medium copy list with random pointers. So it says a linked list is given such that each node contains an additional random pointer which would which could point to any node in the list or null. Return a deep copy of the list. The linked list is represented in the input output as a list of n nodes. Each node is represented as a pair of well random index. So basically what is saying is you have a node which has integer representing the node dot val, and then you have a random index. The index of the node range from 0 to n minus 1 where random pointer points to null, where random pointer points to or null if it doesn't point to any node. So as you can see, what is going on here is that we have to do a deep copy. And what deep copy really means, let me ask you this question. So the deep copy means that there should not be any aliases. So remember two things, like in C especially, when you do something like A equal to B, now depending upon the types of A and B, A could be, let us say, pointer, or A could be an struct. So if it is something like a struct A and B, something like that, and imagine B already has some value. In that case, what happens when you set A to B? When you set A to B, what happens is that either it could be a copy or it could be an alias. So if it is a pointer, especially if it is array, for example, for arrays, it's usually an alias because you just copy the pointer, but you don't really follow the pointer to copy the things that pointer is pointing to. So in this case, it's a copy. But if it was, for example, the case of arrays, it could be just an alias. So you should always remember when you said A to B, is it a copy or is it an alias? So that's what he means by saying deep copy. He's saying your other list should be completely independent of the original list, because if anything in the your deep copied list or the output list has any kind of pointers to the original list, that's not deep copy. That's what he means by that here. So let's try to see how we can solve this problem. So just before we dive into the code, let's take a look at the examples. So the example he's given is head equal to 7 null. So here, as you can see, what is going on here is that you have the value 7 and then the random pointer is actually pointing to null. That's why it's null here. Then you have 13, and 13, as you can see, the next node has the value of 13, but the random is actually pointing to the first node, in this case which is 0th node, so that's why it's 0. Then you say 11, for example. When you go to the next, you have 11 as the value and the random is pointing to 0, 1, 2, 3, 4, and that is the reason why you have 11, 4. So now I guess you get an idea. It can even point to itself. For example, in this case, the random is pointing to itself here, as you can see. Similarly, in this case, you can see this is 3 and null, and 3 and 0, and 3 and null, right? Now, if you have a empty list given to you, then you're supposed to return null. Okay, so I guess we have all the information that is needed to code this problem. So how should we go about it? What I'm assuming is that we would definitely need a bunch of pointers to walk this list. So let's have a pointer on a stem, and then we can have another pointer known as let's just start with the temp first, and then I guess we will need, I'm guessing we would eventually need something to return the new head of the deep copied list. So we probably need bunch of pointers there too. So we have this. Okay, so now let's start by saying that, okay, so what is our strategy? My strategy here is that um, we, what we can do is, given a list, rather than copy them like in a, like imagine you walk it and you, as you, as you're walking, for example, suppose temp equal to head. Now while temp not equal to null, we could also say while temp. First thing is we actually save the next pointer, and we say that is, that should be equal to temp next. And then what we do is, so I guess we also need a next pointer here, right? So we have so that's basically you save, and then what you said is you say, let's say temp next equal to, okay, so what my strategy is going to be is, and I guess most sane strategies in this case will lead to this outcome, where for each node we make a duplicate of it right next to it. So temp next equal to malloc size of a struct node, right? So we have now temp next. Okay, before we do that, temp next val will be set to temp val, and temp next will be set to next, right? Because that's your saved next here. As you can see, we already saved that. So, and then let's say that temp is equal to next. Does it make sense? So that gives you a list where you have a duplicate after each node. So after each node you have inserted, now let's see if we have made sure that our list is not, its integrity is not broken. As you can see, we saved the next pointer of from this list. After saving the next pointer, we overwrote the currents next by the new node, right? Then currents value we copied from the existing node, temp val. Then we set currents that the next is next pointer, so that the chain is not broken, to the next that we had saved. And then we just simply jumped to the next pointer. Okay, so I guess that should do the duplicate. So basically let's call this as duplicate, create a duplicate of each node right next to it, right? Okay, so now let's try to take care of random pointer or random index, whatever you want to call it. So now how can we do that? So again we say temp equal to head, and then we say while temp or temp not equal to null, whatever you want to say. I like to write here in case, because this is a illustration kind of problem, not the production code. I would say while temp not equal to null. That's more clear as opposed to while temp, which is also valid in C, but let's just do that. So now while temp not equal to null, now we're going to say if temp random, then what happens? Then we say temp next random, because we have to, that is the duplicate node right next to it, so we have to copy. Now let me ask you one question. Can I simply just say temp random? I was making this mistake and I think that's wrong. Because why is that wrong? Because let me ask you one question. Would that be a deep copy or not? So you in your, so if you have your, so the idea is creating duplicate of each node right next to it, fixing all these pointers, and then basically decoupling them. So if you have something like this, then do you think the decoupling can be done? Because in your new node, in your new list, return list, you will have pointers pointing to the original list, right? Because temp random is actually a pointer to a node in the original list. It could be null also, and that's why we are doing here this. Now, and then we can simply say temp equal to temp next. Why next? Why not next? Because remember, every node after the current node is in the here right now is a duplicate of the previous node. So if you really want to go, you really have to go two nodes, right? So here, so these two things are done. Now let's try to the decoupling part. So how do we decouple? Decouple these lists. Decouple the list into two lists. How do we do that? For that, we start with this new head pointing to head next, because obviously that's our first new list, first element of the new list. And then we say new tail equal to also head next, like. Then what we can do is new tail while new tail not equal to null. Should it be new tail next not? Let's just take new tail. Now what do we do? So first thing we have to make sure is that, okay, one other thing we have to do is we have to have again start with temp equal to head. Every time you start walking with temp equal to head. So first thing is we say temp equal to, okay, so temp next equal to what? Let me ask you one question. Because we have to now go back to the original list, right? So temp next should be equal to temp next, right? True or false? Because you see, why we are doing this? We are doing that because we want to get rid of these duplicate elements that we created. So temp next equal to temp next, and then new head will leave as it is. We say new tail next equal to new tail next, right? Because now we are only connecting. For example, imagine, like, now this is actually the list that they gave, but imagine we had created a these, like, this would be 7, and then this would be 13, and then it will be 11. So with this 7, we want to now go back to 13, now 13, 11, but these other ones that they copied we made, that's why we are having two layers. I think you get the picture. And so two new tail next equal to new tail next, and with that it should work, right? And here we can simply say return new head. Do you think this is going to work? Let's give it a shot. Okay, member access within null pointer or type struct node, line 49. Line 49, we saying care 14 and member access within null pointer of type struct node. So I think what we need to do is we need to say this. No, that's the line 40, right? Okay, now he's saying it is wrong answer because he gave you 7 null, 13 0, 11 4, 12 10 2, and 1 0. What do you think is going on? Where did we mess up? And he's saying you only gave him 7 null. You never gave him the actual list that it was supposed to be. And why do you think that is um, the problem? And I guess the problem could be, let's take a look. The problem could be that what we're doing is that uh, maybe we have messed up some pointers here, and uh, and that is why it is not working. So let's take a look again where we might have messed up. So if you see the first one, the first loop where we are interleaving these duplicate list and the original list, did we mess up something there? So we have node equal to node equal, okay, so temp equal to head. I see. We are using next actually. That's fine. I think that shouldn't be a problem. Why? So while temp not equal to null. Okay, one other very simple problem obviously is that we should have error check, which I'm pretty sure interviewer would pay close attention to, because you're not taking care of the case that if head is equal to null, then you're supposed to return null. So that was easy. Otherwise, um, let's take a look now. Uh, temp next. I think this part is okay, and then temp next equal. Okay, so I think that was the problem here, no? So temp next, well, so temp next. Um, so the temp was, if you think about it, temp was pointing to the where did the temp started here? So next actually, right? So so I think this line is good as well. Now at that point, I think this part is okay. Creating a interleave in that part is fine. This duplicate. Now random pointer point. Let's see this. Now if temp random, then temp next random. Okay, so here obviously there's a problem, because what will happen is that, as I said, that wouldn't be a duplicate copy, right? If you think about it, temp next is actually end up in the return list, and that will end up having a pointer to in the original list. That's why you have to make sure that the links are maintained, not so much the actual values. So that is why you have to say temp next random of the each duplicated node has to come from the, you have to say where that will point to. That will point to the, because we have interleaved, that would be the randoms next actually, and that is why. So now let's see if that takes care of the problem. We still have a issue. So if temp next random equal to temp random next, else temp next random equal to null, and then temp equal to temp next. I think this is fine too. I think the problem is in the third while loop. So let's take a look at that one. the decoupling part. So we start with two pointers, new head and new tail, and what we do is they're both pointing to the first element of the new list, which is right now still sitting in the original list. And then we say temp equal to head, and then we say while new tail next not equal to null, then in that case we say temp next equal to temp next, that was fine, and new tail next equal to new tail next, and that was fine too. Okay, so I guess these two are fine. Now what is missing then is that, okay, so I see that was a problem. You see, we set temp equal to head, right? And then we are also able to fix each pointer now to the point to the original node. But where is the, we have to also move, right? We have to go to the that original. So after temp next has been fixed to point to temp next, then we have to move, like jump over the copied node so that we can continue to walk. And also after we have fixed the pointers for the duplicated list, we have to again jump. So we have to say new tail equal to new tail next. I guess that was the problem. We were missing, I guess so far we did all right, but we were missing some of the extra code. So let's run it again. Wow, so that's awesome. Basically, it was not a, I wouldn't call this as a very easy problem, because it's kind of a little bit convoluted, actually, to tell you frankly. To do this in O1, I think it tells here, where he didn't say anything, whether you can do it. What is the time complexity and the space complexity? Space complexity is, I would say, ON, because if you have n, a list of n elements, you'll be assigning n elements more, so that you'll be doing malloc n times, so that's fine. That's so on. And then the whole problem is, you see, you're never walking doing a loop within a loop. This is one loop, this is another loop, and this is another loop. So this is pretty much, I would say, 3 on, this is on. So let's try to submit if that works, and then we could be in business. Awesome. So that was a little bit of good news that we had been waiting for a while, because we haven't done any of these problems on Leetcode. And when we don't do Leetcode, we feel bad after some time. So lead coding is the way to go in life. And given that we have solved this problem, 138 copy list with random pointers. I did this as in C, but if you want to do it in any other language, please go ahead. And I think the concepts will remain the same, that you have to walk, basically this whole idea of creating a duplicate of each node right next to it. And then I guess the trickiest part in this whole problem for me was the line 33, temp next random equal to temp random next. When I first was trying this problem, I was thinking, why don't you just say temp next random equal to temp random? But you know, that wouldn't be a deep copy, because your new list will end up pointing to a node in the original list. And the whole idea of this deep copy is that each list has references within its own members, not within the members of another list. So that's why temp random next, if you think about it, that would be the new node of the new list. So that's okay, but you can't say temp random, because that would be like your new list is pointing to the old list, some element in the old list. So I guess with that catch, um, it's then it becomes kind of easier, because the decoupling part is not that hard, I would say. I mean, that's kind of also tricky, that you are basically breaking this list, and which is there until line 37, sorry, 36, into actually two lists now, and they're kind of, you're decoupling them. And other part here is that new tail, which was, why don't we just say while new tail not equal to null? Because you see, if new tail next is null, we would have a segmentation fault here if we go by new tail not equal to null, because new tail may not be null, but new tail next may be null, and then you would be basically dereferencing that. So the loop should go until the next is not null, and so it will go until the last element, basically, pretty much, because then the next will be null, and then so that's it, folks. I guess I hope it was useful, and you enjoyed it as much as I did. I wish you all the best for your interviews, and I will see you in the next video. Until then, goodbye, take care.